All right, good morning, everybody. My name is Michael West. I am a consultant with Catapult Systems, and here today to talk to you a little bit about Windows Cloud Services and how they can impact your lives. I mean, from a day-to-day process. Um, it's a pretty neat time in our lives where a lot of the things that we used to be able to do, um, you, that took a lot of time, a lot of effort, a lot of planning to get done. Azure can really come and step in and take care of for us. So from a developer's perspective, the developer can come in and really focus on his prime goals and his objectives, which is to write good, applications, good code. And he doesn't necessarily have to sit back and, think about all the details and complexities of the infrastructure behind the scenes. It allows him to, really write better code because that's where his time's spent. But then also, sometimes there's times of projects where we all want to have, all of these things done, but there's just no time to do it, or it's not cost effective. And that's something that Azure can kind of step in and, your application can now have, it's load balanced or it has redundancy, and these are things that we would have wanted, but there just wasn't in the budgets to be able to do. Now, there's a lot of confusion about cloud computing and what it is and what that means for different people. And there's a lot of terms thrown about, infrastructure as a service, platform as a service, software as a service. And we've touched on this a little bit earlier. Infrastructure as a service is, it is really just the virtualization of hardware up in the cloud. Software as a service is, provides a consumable service for someone to be able to use. Azure really fills in the platform as a service by giving an intelligent platform that really takes away and abstracts a lot of the complexities and a lot of the things that you have to deal with when you're trying to run applications. Now, cloud services, they allow you to deploy code that's really easily, quickly scaled up or down depending on your needs. So, there may be times where you've developed a website and you've got it published out here, and let's say you're a seasonal company, and there's going to be times where you've got a lot of high traffic. So you're able to scale up and be able to meet the incoming traffic, and then as things slow down a little bit, you can scale back down, and that way it's a little bit more cost effective for you. So you can also you can always kind of find that performance to cost ratio and how that's going to benefit you and what you need to do. And luckily it's very flexible. So it can change just depending on your needs. And provisioning of the services and just provisioning in general for Azure has been something that I've noticed that has just been a huge benefit. As a developer. Sometimes you want to be able to go in and have a dev environment, you want to have a QA environment, you want to have a production environment, and ideally these would all completely mirror each other. But a lot of times, realistically, it's hard to procure servers that aren't shared resources, or there's just not sitting around the company, and so getting these procured takes a lot of time, effort, and sometimes they just don't exist. So it's been a great thing to be able to have Azure kind of step in here, and within minutes I've got a dev server, and then I've got a QA server, and the code can transition from one place to another very, very well. So that's been a great benefit as a developer. And beyond that, I guess you start seeing things where it can be beneficial to you. So that process that you create, and it may be put on a server, and 10 years from now nobody knows what's going on with it. Maybe it's an important process, but everybody's just forgotten about it, and it's something's running on this box. Somebody comes in and deletes it, doesn't know any better. With Azure, you can take some of the processes that might run on that server that are not necessarily products of the company, and put them into Azure, and that way they have a safe place to run, and it gives them a little bit more visibility. So it's a little bit harder to just run in and say, we don't need this, because there's some reason we put it up here. Now, setup for cloud services is usually it's just as easy as building your code. So there's not a whole lot that we have to go through and do. You do have options. So for instance, let's say Azure is going to take care of patching the OS, but you may have requirements where for federal regulations, FDA, you need to be able to have the OS locked down and do your own patches. So you are able to go in and choose a specific build of an operating system, and then patch it as necessary, as you see fit. So through the build process, what's going to happen is as you're developing, you're going to create something called a service package, and the service package is really the deliverable. It's the deliverable part of your solution. And we'll talk a little bit more about what comprises a service package. But just, for right now, all we really need to know is that this package, we're going to upload it in Azure. So we build this package. We're going to tell Azure how many servers we want and what size they're going to be. And so once we've allocated these virtual machines, and we've said, okay, we want 4 instances here, the code and the configuration for that package is shared through all of those. So and once we've got the code deployed on there, of course the virtual machines get spun up in the data center, and really within no time at all we can have 2 or 4 or 10 or however many instances that we need to be able to handle our incoming traffic. And so once they're there, a great thing that we get to benefit from here is that we get a network load balancer for free, and so the load balancer will come in and handle requests in a round-robin fashion. So it's just it's a beautiful way to be able to kind of scale out your application and be able to handle more traffic. So, when it comes down to, what a cloud service is made up of, and as Noah was saying earlier, I mean, it's a way to look at it is an organizational detail. So you want to take a group of related roles, something that's going to perform, a certain aspect of, a project, and, those would work in tandem together. But then it's also, it's kind of the different elements of the cloud services, comes down to what's going to be running in it. And that's either going to be a web role or a worker role. So a worker role is, the way that I look at it is it's a worker role is something that's going to be running background processes. It's kind of all auxiliary or supportive functions. I mean, it can really be anything that you want to have on there. It can do any types of jobs that you need. And here we see some of the common patterns. We've got a queue worker, a listening worker, a process worker. And just depending on what you need, the queue worker may, go ahead and pull the queue, get some messages down, and do some image processing or, any kind of long-running process. The listening worker, you might want to have a WCF service, that's not an IIS, WCF service running on it, and doing whatever you need to have it done. Or, the flexibility is there for you to really start any kind of process that you need. So, just like any, you can just call process start from .NET, and run any type of thing that you want to have. So, whether that be, like a database server or distributed cache or, whatever you need to have it done. Now, the web role is an extension of the worker role. So it's going to have all of the features of the worker role, but then in addition, it has the IIS hostable web core. And, so it's going to respond to incoming traffic, and it really can be any type of website that you want, whether it's a traditional ASP site, an MVC site, WCF service, whatever you need to be able to put up here. And so it's going to listen to traffic on HTTP, HTTPS, various protocols to, to be able to respond just like any other website or service. So the roles themselves can really run just about anything that you want to have on them. And the general rule is that if it's going to be able to run on Windows, then it can run in Azure. So, you know, you know, pretty much you're able to come in here and when you're developing, as we've talked about, you can, choose whatever language that you want. So, just whatever tickles your fancy here, whether it be C# or VB or, PHP, however it's best suited to you. Obviously, choice of frameworks to be able to go along with that. And when it comes down to what can you put on the machines, I've had instances where we had a WCF service installed, and this was for a group of engineers, and they needed to have MATLAB installed on there so that the service could actually use some of the components of MATLAB. So we're able to to remote into that box and install MATLAB, and have that shared between people. There's another time where we had a website up, we had a web role, and we needed a little bit more information from a code profiling perspective. So we remoted into the box and installed our code profiler, and it was really able to do whatever we needed to with that. Now, a cloud service is really, it's defined by roles and instances. It's really, the service model for a cloud is defined by the roles it'll have, the endpoints that it listens on, and the size of the virtual machine it runs on. And during runtime, you tell the role how many different instances that you want to have it run. And so, and this can change actively during runtime too. So you can scale up or down, and when you look at the virtual machines that's running this role, each virtual machine is going to be given one and only one role to run, and that has been a really huge benefit too. Where you develop some code, you're putting your application on a server that maybe be shared with somebody else's. And there's some type of side effects that happen. You never know what you could run into, or even times where you've developed something and it's your own application and your server is dedicated to you, but there's some trailing things that have happened years back and that you haven't taken account for, and sometimes some oddities can happen. One of the great things about Azure that I've seen is that for one, you've got the single purpose, so it's not being shared with other items, and then also it's a clean environment. So every time you're putting up a new deployment, it's brand spanking new. So it's you don't have to worry about what else might be lingering back there, waiting to rear up its ugly head, right? Now, what we see here is, let's say we've got a web role and a worker role. So, our hosted service is, comprised of these things. The web role is set up to, it's got about 10 instances. It's set up to kind of handle any kind of incoming traffic. The worker role's got 6 instances, so, you can vary, however you need it, and, whatever support level that you need to have. So, and it's great being able to have multiple instances and just like that, be able to spawn one up. But as soon as we have, multiple instances, there's other things that, there's other, kind of requirements that we have to take into account. And that's, routing and load balancing, machine failures, and, the upgrading process. Now, talking about load balancing, we've got this round robin that's happening, right? But we want to be able to look at the role life cycle and see how that feeds into it, because the load balancer is intelligent. So it knows when a web server is up, and it knows when to be able to send out requests to different instances. So when we look at the role life cycle, a role is going to be very similar to a Windows service. It's got the onStart method, it's got the run method, and then an onStop method. When the Fabric calls the onStart method, that's a place for you to be able to write any kind of initialization code, something that's going to happen one time in your application. And it's going to raise up events to let the Fabric know what its status is. And you're able to check that through the portal as you're doing installs and whatnot. You'll be able to get this feedback to know where it's at. And then the Fabric's going to call the run method. And the run method is really this is the meat and potatoes of what you're doing. So it's just something that's going to be in an infinite loop that you won't want to exit out of whatsoever. And then the on-stop method, that provides you a hook in there to be able to go in and kind of do any tidying up, cleaning up of resources that you need to, and you'll have, I think, about 30 seconds to be able to take care of any of that. So, and so, anyways, so the load balancer will be able to use that. So, if the role is in the busy status, whether it's starting or stopping, it's not going to send requests over to it. So it's only going to send requests if it's in the run status. Now, fault domains, which we talked about a little bit earlier, is it's a single point of failure. So it's it could be the analogy of being a server rack, where all of these are plugged into the same power outlet, and so that allows the infrastructure of Azure to really be divided into multiple sections that don't interact with each other. So, or they're highly unlikely to really impact each other. So if you have more than one instance, you've got a great uptime guarantee. And so you've got one instance that's going to be installed in one fault domain. You've got another instance that'll be installed in another fault domain. And all of this is kind of taken care of for you just during the Azure installation. So it's not things that you have to designate or that you would want to designate. So these places right here, it's really just kind of a physical boundary. Once you have this set up, it gives you a lot of security and knowing that if something does go down for you, your site's still up, it's still available. So it's a very, very helpful part there. Now, upgrade domains are, they're a little bit different. Where fault domains really refer to a physical location, an upgrade domain is more of a logical boundary. It's more of a logistical process. And what it is an upgrade domain is kind of a grouping of instances that are within a role. So you can imagine, let's say that we had an upgrade domain, or we had a role with 2 instances, and each one of the instances are in different upgrade domains. When you go to do a deployment, an in-place deployment, it's going to take the first upgrade domain down, install the code on it. All requests would be routed over to the second upgrade domain, and then it'll bring that one up, and then of course bring the second one down, install the code and whatnot. And now this is not just it's not a one-to-one relationship between instances and upgrade domains. You may have 4 different instances in an upgrade domain, or you may have however many different instances that you need. You don't really have the control over what instances are going to go into the domains, but you can specify how many domains that you want. The default is going to be 5, and you can go up to 20. Up to 20. Now, an alternative to deploying is called the VIP swap. And this is something where every Azure environment has two different areas. It has a staging and it has a production. So if we're looking here, we've got some code up here running in production. Let's call it version 1. Through the development process, we decide to create another deployment. We got version 2 that's coming in. We're able to take that and install it into our staging environment. It's got its own URL, different from your production, so you're able to access it just with a different address, right? That allows you to be able to go in. You're able to take your code, put it up into the cloud, do all your testing, your evaluation. Make sure that it's really ready for prime time. And once you feel secure and you're ready to go ahead and make that deployment into production, what the Fabric's going to do is it's going to tell the load balancer to switch out the IP addresses. So where you have the public IP address that everybody's hitting, you've got internal IP addresses, pointing to each virtual machine. And so it's going to say, okay, this grouping over here, when a response comes in through the public address, instead of sending it over here into production, it's now going to get rerouted over into the staging environment. So it's a very quick process in that you can switch these 2 environments, right? And staging then effectively becomes production, and production becomes staging. And a really kind of a good feature about this too is that if you've deployed code into staging, you've done your testing, it was ready, you put it into production, and then a week later you find some critical aspect of it that's just you can't live with, and you need to be able to revert back to version 1 of the software. It's very easy for you to just do this VIP swap again, and now you're back to your original running code, and that allows you time to be able to go and fight fires and figure out what's going wrong. Well, now session state is something that you really want to you have to manage differently. So you don't ever want to use in-process session state. You can use a state server. You can use distributed cache. And let's say I still don't believe it's supported, but you're using SQL Server session state. Your connection string that would be in the web config would point to that one. So as it would retain the same state. It would depend on how you have it set up. So let's say my staging was pointing to a staging database. You would want to go ahead and change that connection string over to your production. If you had session, okay, I see what you're saying now as far as session state in there. I'd have to think about it to see what would be the route. It is. I would imagine that there's probably ways that you can transition things over, but it would take a little bit of planning. So, yeah, the load balancer wouldn't do it. It's probably going to take some extra planning on our parts to be able to make sure things transition over. Yeah, and when you're upgrading your application, I mean, there's a lot of considerations that you want to make, and that's where do you do the VIP swap, do you do the in-place upgrade, and each one of those kind of has pros and cons. So the VIP swap, it allows you quickly to swap environments, but then some of the downsides to it is that you're not able to add in any endpoints. So the addresses that you have right there, it's not able to create them, but it just kind of switches things around for you. Then also, with the VIP swap, once you're going from staging to production, it's a quick process, but there could be a request that comes in right during the transition period to where that request goes into a service or to a site, and it doesn't get handled. So there is that possibility. On the other hand, you've got the in-place upgrades, and that's going to do kind of a rolling upgrade on a live service, and with that, you're going to be utilizing the upgrade domains. So, but then you want to be able to kind of figure out how many upgrade domains do you want. Like I said, the default was 5. We can take 2 different examples. Let's say that you had 2 upgrade domains. And when you went ahead and did your deployment, the first one came down, and so all requests are routed over to the second one. Well, now your site has just halved its performance. So and that may or may not be acceptable. It just kind of depends on what you have. But you're guaranteed that at any one time you only have one application up and running. You can mitigate the performance issue by adding extra upgrade domains. But let's say that now you've got 4 upgrade domains. So you're doing a deployment, the first upgrade domain comes down, you deploy your code onto it, it comes back up, or while it was down, all the requests are being sent out to the second, third, and fourth domains. As it comes back up, the second one goes down, we're deploying code onto it. Now as request comes in, they can go to the first, third, or fourth domains. So there can be a point where your website might be different, and that may or may not be acceptable, just depending on what you need to have done. So it may be a small change, it may be something drastic, it may be something that kills your application. So these are all kinds of considerations that you need to be able to take into account when you're doing your planning for it. But before you even get to the point of deploying, you want to be able to build your code and run your code. And what through the Azure SDK download, you'll get tools. You'll get tools with the Visual Studio that allow you to really kind of have a cloud in a box. So they're going to emulate the cloud environment, and it's going to be sitting on your box. You don't need an internet connection, anything like this. So you can go in and do whatever type of development that you need to. With that comes a cloud the cloud emulator, which is a compute emulator, which will really kind of stand in for your instances, and a storage emulator, and that will be the Azure storage. You can view what's happening with those once you peek into the emulators. You can see which instances are being hit, and just various different pieces of information about that. And then Visual Studio has extra tools in which obviously you're able to create your cloud project. You're able to create roles, configure roles, things of that nature. But then you can also, if you want to be able to look what's in your storage, you've got the Server Explorer, and so you just point to your storage through Server Explorer, and you're able to go look at the tables and see what information's in there. And I believe, I can't remember if this was always the case. For a while, I think it was read-only, and now they've got it to where you can delete and edit items that are in storage too. So when it gets, when we were talking about the service package earlier, the service package is really kind of comprised of two different things. It's your code that you developed, and it's the service definition file. So those two things are going to be zipped up together, and you upload those to Azure. Along with that, you have a service configuration file, and this definition and the configuration file kind of run in tandem together. So and we can look at the service definition file. Really, it's similar to a header file. So you'll define the elements in the service definition, and those will be fleshed out in the service configuration. It will also, it does do some things where it's not just definitions, where it's going to define your roles, your endpoints, your VM size, and these are things that you'll find only in the service definition. Well, this would be part of the provisioning process. There's multiple different places where there's some things that are going to take a full deployment to re-provisioning, and because this is all part of the provisioning process right here. So the deployment is the provisioning, I guess you could say, and then there's some things that you can change actively while it's running. So right here, you see example of the service definition file. You'll just notice limited information. It's got import module name equals remote access, and that's going to be defining the remote desktop connection that we'll see in the configuration. You see your bindings there. Which endpoints is your website going to use, and then your endpoints down here at the bottom. So we're going to be listening to HTTP on port 80, right? Now the configuration, he's going to be sitting here to change any kind of things that that actively are going to be modified during runtime. So it really kind of stands in like the web config. So the web config, which there's still a lot of values that you'll have to put into web config, different types of connection strings. Let's say you're using some type of provider access, or I have session state. That's where you're going to be able to define that. And so there's different things that you'll have to use for web config, but keep in mind everything that you put in the web config is read-only. If you need to change something, then you want to be able to put it into the service configuration, or the database or storage tables, or some other mechanism to be able to put that in. It contains really kind of a lot of the detailed information. So we'll see. We've got the remote access up here, and it's got properties just kind of tagged on to the end of it, enabled, username, password, expiration, and you'll see the values that are put in here. Then we also have a certificate right here. It's going to define the name and then the thumbprint for that certificate. Now, when you're looking at, what size of VM do you want to provision? What do you need? The best route is not necessarily just going out and getting the largest server. Um, the larger the server you have, the more CPU cores that you have. So you have additional processing power. So if you're doing something really CPU intensive, like video editing, image editing, crunching numbers, something along that lines, then that might be the route that you want to go. But then it may not be cost effective for you because obviously it's going to cost more for the larger server. So you might benefit more from going down to some of the smaller instances and having multiples of those. And having multiple instances is going to give you more and more redundancy. So you can kind of play with that and figure out what's your best cost ratio. And it's real easy to be able to change this through your development process. Start out with a medium-sized instance. If that's where you've kind of gut filled that's what your site or service is going to need. Run some load tests on it. See how it worked out for performance, and if it's not enough, go ahead and scale it up. Right. During the lifetime of your application, sometimes the applications change. So, 2 years from now, your application, which only needs a medium instance, may need an extra large instance. Maybe some additional features have been added into it. So it's easy to go ahead and create this new server, on the fly for yourself, as to where, in your own office, that may or may not be so easy to do. Networking in Azure, you have a little bit of control over here. There's a couple of different endpoints that you want to talk about, and that's the input endpoint, the internal endpoint, and the instance input endpoint, which is a complete tongue twister for me. The input endpoint, you're looking at kind of your public site, and that's what's load balanced for you. Your internal endpoints, you've got instance-to-instance communication, and then your instance input endpoint allows you to talk to a specific instance while let's say you're at your company and you want to be able to speak to a specific instance, and you're able to define a port range, and that port range increments up, and it relates to the different instances that you have. So for whatever reason, if you need to talk to instance 1 and then instance 2, you can do that. Name resolution. For the most part, most of the times, most scenarios, you're just going to want to use the Windows Azure DNS server. So it's going to handle all of that for you on the background. And that's usually exactly what you want. But there may be situations in which you need to have your own DNS server. So you can bring your own in here. And there's places in the configuration for your virtual network where you can define that. You might have a virtual machine that's sitting up in the cloud, and you need to be able to talk to it with a machine in your office and have a name resolution for that. So you have the options to be able to do whatever fits your goals. And then of course we have the load balancing and the traffic manager. The traffic manager gives you a little bit more control about how you want traffic to be routed to your different instances. So, the round robin is definitely one way that it can use, but it has a couple of different other methods. You may want to use the failover method where, you're going to have one primary instance, and that's what's going to get all of your requests until it goes down, and then it would go to the second instance, and so on and so on. You can also change that up to have it do more of the performance method, which, if you look at an application that might be globally distributed, different areas of the world, when a request comes in, the performance method is going to take into account where that request is coming from, and then service that request not necessarily from the closest location, but from the location that is going to be the most time expedient. So, so these are different different methods that you can kind of control and get how traffic gets to you. Now, local storage, and this kind of goes along with session state. When you're developing your applications, you want to make sure that it helps you develop well architected applications that the session state for the most part, can be as stateless as possible. Um, when you're doing session state or local storage here, local storage is on the virtual machine, you're able to define a directory that is used for local storage. But whether you're doing session like in-process session or this local storage here, what happens is, imagine you got 4 instances and I write to the drive on this instance over here. That is not carried over to all my other instances. So if I write to session state, it's not carried over to my other instances. And so the first request would go here, we'd write it and expect it on the second request. It would hit the second instance and not be there. So obviously problems, right? So you're able to use these things because you can still put items in there that are not integral. So cached images, things that you can quickly access, but if they're not there, you can quickly rebuild too. So it's good also to keep in mind with the local storage itself that it gets once the role gets recycled or the role gets redeployed, then that local storage is deleted. So it's definitely not persistent storage. You can make it a little bit more persistent by there's the clean on roll recycle, and go ahead and set that value to false during in configuration. And what that'll do is that keeps it from being erased if the role gets recycled. And your role could get recycled if you make some type of configuration change, or if there's an unhandled exception that gets thrown in your application, and go and it would recycle at that point. You may or may not want to have your disk wiped out. So you can use it for good for cache resources, but definitely want to use your storage tier for any persistent data, whether that be SQL Server or the Azure Storage, distributed cache. Any of those are good options to be able to put things in. Well, the cache is not necessarily persistent, but to be able to put it in to have it across different instances. And that brings us to Azure Diagnostics. And diagnostics is, just as the name implies, you're able to take your website, put it up into the cloud. Your website, I use website, but it could be website service, whatever you have running up there, and still needs some insight into what's going on with it. And that may be for performance reasons. It might be for your cost. You want to see is it effective for us to have this large instance up, and so you need to be able to get some of the details. Or it may be debugging applications and just having the logs that come up. So you can define different stats that you want to pull in. Do you want to get the Windows logs, event logs? Do you want to have IIS logs, Azure logs? There's multiple things that you can put in here. Performance counters, you can tell it to go ahead and track those and which ones you want. And those are written over into the Azure storage. So so each one of these, the Windows event log will be written into the Azure storage table specifically for that. And then you have tools that can come in, as you were looking at the Azure store earlier, and other kind of tools that you have just out in the system that will allow you to take that data, kind of mine it, graph it up for you, and that way you can really make educated decisions on what's happening, just like as any kind of other machine that was in your own network. So just a lot of flexibility here all the way around. Once again, it gives you you can get into the details of the infrastructure and change some of the things that you need to have modified for your particular situation, or you can be as ignorant to that as you want. Just depends on what you want to have, what you need to have done. And it's a huge benefit when you don't have to worry about all of these trailing items. It makes a developer's life very clean, very easy, and it's been something it's really been a godsend to me over the past couple of years to be able to handle all of the different situations, and the opportunities to be able to do things have really grown too. Where it's just easier to get these machines up and running, even for temporary times, and you can really kind of accomplish a whole lot more tasks than you normally would have.